Hello everybody, I'm Nick, and every now and then I see this exact question posted on Reddit, LinkedIn, Stack Overflow, my own comments, and it is, why do you prefer classes over structs? And basically, what's the difference between a class and a struct, and why shouldn't I just use structs all the time? Because they act a certain way as value types and classes are reference types, and when does it make sense to use one over the other? So in this video, I'm going to take a look at this post, the comments, and also show you code to explain why you might want to make that choice. So the question here, or the post here, says that in C you have code that represents data, structs, and separately you have code that represents functionality. In C#, this boundary gets smeared because both classes and structs can both hold data and have functionality. Now, I was taught that in C#, a type should always be a class unless there's a very good reason for it to be a struct. Now, why is that? Why don't we program in C# as we would in C, with structs only hold data and then some classes provide the functionality of the data? Also in C#, you sometimes have a type that is simple enough that only contains data but no functionality. If I have a type that, say, only has 3 fields properties of the type string, what is the reason to make it a class instead of a struct? Is there some deeper reason? There is. I understand the difference in semantics between value types and reference types. I understand that stack frames live on the stack and classes live on the memory located in the heap, but it doesn't really explain to me why it's so bad to use C# in a C-like manner. The last part basically explains it for themselves, but I don't think necessarily they get it. So let's just look at the comments before I go into the code. In your example, an object has 3 properties that to me is a valid case to use a struct. Yeah, but you're using a string. A struct is appropriate if you want immutability and it's small enough that you won't take a performance hit by passing by value. What does that mean? Well, here I have an example of having an example class and an example struct. They both have an integer and a string as a parameter. Now, classes are reference types. They're always allocated on the heap. There's some edge cases, but you should treat them as if they're always allocated on the heap. Structs are value types. They will be allocated on the stack when they can be allocated on the stack, but when they can't, they might get boxed and then they will be allocated on the heap, and they can also be allocated on the heap in some other cases as well. But in this case, I have a struct and a class, both with my name. This string will be allocated once because it's a compile time constant. Could also be a string literal. In either of those cases, it will be interned, and then we have the age over here as an integer. And then I'm calling this method accepting both things, and in the end, I'm just printing the name. Now, I just want to show you over the flow and how memory reacts here. So I'm going to just debug it, and I'm going to, before allocating the struct on the stack, I'm going to load memory and show you all the memory of my application over here. That's the heap, not the stack. Now, if I step over the struct and I reload memory, you see there's no difference. There's no delta between what I had before and what I have after in terms of memory, because this is allocated on the stack frame, which is popped automatically once you're out of the stack frame. And that's why we don't need garbage collection for stack allocated values, because that memory is encapsulated within that stack frame. And we know for a fact that if we just pop it out of existence, it's not going to affect anything else. However, when I go over the class and then I load it, you're going to see that this example class thing has been allocated. It's on this address over here, and I can see these values. And in this case, because this int32 value is a value of a backing field, which is what's behind the property, even though it's a value type, it is allocated on the heap. Now, if I step in here and I go in the method, this class object is the exact same as this one. Anything I do with this class object here will affect any other reference of that object, including the one over here. However, this one here, the struct, is a copied value. C# literally goes over here and says, I'm going to give you an entirely new version of this struct over here, which I can do whatever I want. If I just open this window, say example struct.age equals 10 instead, and I evaluate it, then this value will be 10 on the struct. However, this one over here, which we will see when we get out of this, again, this is still 10 over here because we changed it. But when I go out of it, this struct is still unchanged because this value is detached, is a separate thing. It's not copied into the method. It's the same thing as passing an integer or any other value type, basically. However, you can, of course, go and say, pass this struct by reference. And if you did that, then as you might expect, I'm going to go here. And now nothing was copied. If I actually go here again and I step in and I do this exact same thing, so example thing equals 10, then yes, now this is 10, but when I go out of it, it is still 10 because it was passed by reference. It wasn't passed by value. It wasn't copied. So that's a very important thing, because the bigger the struct, the more memory you copy, because you create a whole new memory for that stack frame, while the only thing that the reference type, like the class over here, has to copy is the reference, is the pointer to that address that will eventually be resolved to get the values inside that class. I can also, if I want to go full old school, I can do something hacky like this. I can say that this is a pointer, this is the address, and then get this from over here. If I just enable unsafe code over here and I make the local function unsafe. In fact, I should probably be able to just surround the entire thing with unsafe. Then if I run the exact same code over here, and I actually went all the way down here, then you're going to see, no pun intended, that as I step in here, I have the address. The address is this thing on the memory that points to the struct, and I can actually see inside the pointer, and then I can get the value, and I can go here and I can print both values because I'm getting it through the pointer. You get the idea. This will also, by the way, because you're passing by pointer, allow you to do something like age equals 10, for example. So you will be able to change it if I say age here and age here, and then I also say example struct. I can simply just do this and say example struct.age. Then as you're going to see with everything changing, even though I'm changing the value in here because I'm passing by pointer, I'm going to change the value. You get the idea. Don't do this. This is also a very dodgy way to do it. Not recommended. But all that's to say, you are copying a whole ton of memory, which can actually slow you down. And there's many details on structs and how they're copied. There's so many things that you have to worry about. But the main thing is, if your struct is big, I think the official guidance in terms of size, and this is coming from a 2008 book, by the way, so things change, but the official guidance is it has to be under 16 bytes, your struct. I don't know about that. I'm sure Microsoft in their code, they probably copy more. But the general idea is you have to keep them small. Otherwise, you will take a performance hit, because even with the garbage collection and everything, it will be less efficient past a certain amount of copying. Plus, copying things in the stack can lead to stack overflow as an edge case as well. That's where the exception is coming from. So there's many people over here trying to help. Some people say less than 64 bytes. What I've seen is 64 bits. I'm not quite sure. I haven't really caught up with that latest thing, but the advice here is you probably need a class. I agree. If you're running into performance issues, run a profiler and see what causes the issues. Is it memory related? Then spend time learning about memory and performance. Decide if using value types will solve the memory related issues. Then you need structs. Otherwise, then profile again and see if you solve the problem. This is a great comment. This is a great way to tackle it. But the truth is, it is very unlikely that if you don't know why you need structs, that you're gonna need structs. Just the prospect of them existing isn't really something that you should be fixating on to use, because they look like a thinner version of a reference type, just because we know reference types are allocated on the heap and garbage collection make things slow. Copying things can also make things slow. Don't abuse structs. If they're thin, small, and you know exactly what you're doing with them, then fine. But I've seen many junior developers and mid developers use them and not quite understand how they work. So be very careful. But now I wonder from you, what's your take on all this? And when do you think people should be using structs? Leave a comment down below, let me know. Well, that's all I had for you for this video. Thank you very much for watching. And as always, keep coding.